Okay, well, we're getting started. Today we'll talk about data visualization. Just a friendly reminder to take your daily symptom monitor survey in case you forgot to do it. But are there like reminders posted everywhere, or you guys just know to do it every time you wake up and you just gotta punch your stuff in? Okay, well, anyway, so data visualization, this is all about making graphs, right? And our textbook starts with this chapter, and my notes today are basically coming straight from the textbook. I've made a few minor modifications to some of the graphs and charts, but pretty much I'm following the textbook exactly. This is chapter 2 in the textbook. I do hope you're, I don't know, at least keeping up with some of the reading. So on Friday we covered chapter 1. Today we're covering chapter 2. Anyway, it starts off, very first sentence, data graphics provide one of the most accessible, compelling, and expressive modes to investigate and depict patterns in data. And the truth is anyone can make a data graphic, all right? But to make a good one, it takes mastery, knowledge, and insight, okay? And our textbook compares it to cooking, okay? So anyone has access to, say, or a lot of people have access to, say, a stove or a microwave and can kind of prepare food. But in order to make delicious meals, it takes skill and practice, and you have to know what you're doing. You got to be familiar with your tools and your ingredients and things like that, okay? So anyway, we're going to follow the exploration of data from the 2012 federal election cycle. I guess it's almost 10 years ago now, and you guys were probably what, like 9 when this was going on? I don't know how old you were. Okay, so you're think back to when you were in 4th grade or something, and there was a presidential election. Okay, Obama was running for a 2nd term as president, and Mitt Romney, the Republican candidate, was the challenger. Romney and his vice presidential candidate, Paul Ryan. During that election cycle, there were also races for seats in the House of Representatives and also the Senate. And just also background information, there are things called PACs, political action committees. I guess you can call them super PACs and stuff like that. Basically, these are companies, corporations, and they're allowed to spend large amounts of money on advertisements for or against a particular candidate. And there's also all of kind of these political donations and political spending is kept track of by the Federal Election Commission, okay? And this is because, advertising works, okay? Advertising does influence people's behaviors, and as much as we like to think we're immune to advertisements, the reason why you see so many videos in front of YouTube, your YouTube videos, and these pop-up ads and all of these things everywhere online, is because it works, right? Even if it's not like 100% of the time you click on one of these things, but even if it's like 0.5% of people who view this thing, if it affects their behavior, then it can be worth it, all right? And so advertising works, and so as far as elections go, people spend money on advertising to try to get their candidates elected. Okay, we're not going to show it today, but a lot of work was needed to kind of compile the data. We're going to get into some of that stuff later on in the course, but today we just want to kind of look at some pictures and say, this is the stuff that we have to kind of think about, right? And so one of the questions is kind of like, who was the more popular candidate, right? Who gave more money to, or who earned more money, right? As far as their election candidate, their campaign, right? But this is a really tough question, and it's not as meaningful as you might think, because because of all of these kind of convoluted campaign finance rules and networks and stuff, and you can donate to the Political Action Committee, and you can also donate directly to the candidate, and the Political Action Committee can spend money on the candidate's behalf and things like that. Trying to figure out how much did each candidate raise, it's a little bit of a tougher question. But what you can do is we can ask how much money was spent on each candidate, okay? So we could say, well, how much money was spent on each candidate? Because that's also tracked by the Federal Election Commission. So basically when they run an ad, you say, is this ad for, someone, or is it against someone, or, is it supporting maybe the proposition or something like that? And here we're just looking at spending on candidates, okay? And so we can go through the data and we can just say, all right, which candidates was there like over $10 million spent, okay? And during the 2012 election cycle, there were, I guess, it looks like seven candidates where at least $10 million of advertising was spent, okay? You got, and we can see that kind of the two biggest ones, we have Barack Obama, and we also have Mitt Romney, Paul Ryan. These are the two largest amounts of money spent. We also have some other people, Tommy Thompson, Richard Murdoch, Josh Mandel, Tim Kaine, and George Allen. I don't know if any of these names sound familiar. Tim Kaine was the vice presidential candidate in 2016. But anyway, these people were also up for election, okay? And anyway, and there were lots of people up for election, but they didn't, $10 million wasn't spent on them. And so this is just kind of the graphic that shows that. Okay, and so what this looks like is it looks like, okay, there was a lot of money spent on Barack Obama, and maybe like less than half of that spent on Mitt Romney, okay? And you go, oh, okay, well, maybe Barack Obama raised a lot of money. But this actually doesn't tell the whole picture, all right? And this is a key reason why familiarity with the subject matter. We talked about the data science Venn diagram, and one of those things is domain expertise. You have to kind of be familiar with the subject matter, right? And maybe some of you guys are very much into elections and campaign spending, but I doubt most of you are, okay? And one of the things is that if you're familiar with the data, or if you're at least familiar with kind of this field, is that this election spending, when we talk about how much was spent on each candidate, that can actually be broken down into money that was spent supporting the candidate, money spent working against the candidate, okay? And again, you would only know this if you were kind of familiar with how some of this stuff works. And if you're not familiar, these questions, these ideas to say, hey, let's split the graphic this way, or let's try to look at this thing, might not even occur to you, okay? And so that's why domain expertise is very important. And it's not to say that you have to become an expert in everything, but it's very, very, very dangerous to approach a data set if you don't know anything about it. And you should at least, if you start working on a data set, you should at least try to pair up with somebody who's familiar with the subject, because they'll know the questions to ask. They'll know the kinds of things that you should do and break up. And so again, that plot tells us that most of the spending was on Barack Obama, and the second most was on Romney and Ryan. And that, of course, that makes sense. They were running for candidates. And these are some of the other candidates in the graphics. And they are just kind of senators. And these were kind of like closer races, right? So Tim Kaine and George Allen, they're right here. And over $10 million was spent on each of theirs. And they were running basically a hotly contested Senate election in Virginia, okay? And a lot of these were also other just kind of Senate races, and basically senators are seen as more politically valuable than House of Representatives candidates and things like that, because they're elected for 6-year terms, and each state only gets 2 of them. There's only a total of 100 and things like that. So anyway, these you can read more up about it, okay? And so, did Obama raise the most money? Okay, the most amount of spending was definitely on Obama. But again, like I said, it could be spent, the money spent on a candidate could actually be supporting or against. And so we should take a look at this. And so what we can do is we can take this graphic and we can color it, okay? We can color it based on the type of spending. And we can see that all the money spent on Barack Obama's candidacy, a lot of it was spent working against him, okay? This whole thing being red, or whatever color this is, there was some money spent supporting and money spent against it. Is anyone from like a swing state like Ohio or Pennsylvania or anything like that? Where are you from? North Carolina. Okay. And so those of us who grew up in California, you're kind of lucky in that you've been shielded from so much political advertising, okay? It's like during the elections, we hardly ever see ads for the president, right? I don't know. Have you ever seen an ad? Did you ever see an advertisement for Mitt Romney on TV? Probably not, right? Or even supporting or against Barack Obama on TV? Maybe like one pro ad or something. It's very rare in California. Whereas I imagine in North Carolina, it heavily dominates, right? I have friends from Ohio, and it's like every single advertisement during election season is just political ads, and they're almost all negative. And it just kind of like really brings the atmosphere down. It's just like negativity on TV. This and this person has done this and this and this and this, and they're terrible. And and that's what a lot of what life is like if you're in a swing state like Florida or Ohio or Pennsylvania or things like that. So you can see. I don't know if you are aware of how much negative advertising there is. And so both the advertising spent on Romney's campaign and Obama's campaign, most of it was negative, but especially in Obama's campaign, like I think this is like 92% of it was negative. Over here, it's maybe about 70%, okay? And actually the amount of positive spending on Romney's campaign was higher than the amount of positive spending on Obama's campaign. It was less. And so if you actually assume positive spending on Obama and the negative spending on Romney is kind of like the Democratic spending, and then this over here being the positive on Romney and the negative on Obama is like Republican spending, you can see like there was a lot more money spent by the Republicans than the Democrats in this case. Yes, question?
Isn't it's under like the Barack Obama class or whatever? So that means that it's not necessarily spent by the Obama campaign, but just about the
Right, because the campaign spending rules are weird in that, so the candidate themselves has money to spend, okay? And then there's kind of like this, after the Citizens United decision, there's like, oh, you know what, we can pop up little companies that will spend money either for or against a campaign. And it's like it works around certain, I don't want to say loopholes, but it's just kind of like another system in how to get advertising, political advertising and things like that. I'm sorry, you also had a question.
I was gonna ask, isn't the red bar like for Obama? Does that mean that he spent that money against, let's say, Romney?
No. This is again. So this money that appears here is all. It's from different like corporations. Okay, so there's a bunch of political action committees. They're like little companies, and they're not necessarily endorsed or supported by like Obama himself, okay? So sometimes you'll hear an advertisement and say like, I'm Barack Obama and I endorse this message, right? That was an advertisement created by the Obama campaign, okay? But then there will be other advertisements and it will end by paid for by, Americans for Freedom or paid for by Americans for Justice. And it'll be like just some patriotic sounding name, but it's like, oh, who actually funds that? And you don't really know until you like dig into it, and they'll be like, oh, we're a political action committee that's working to support this and this person's campaign. So this money was not spent by Obama's campaign, but this was just during the federal election cycle, and the commission, they have to say, all right, we are this political action committee, we are spending money, and this money is going to be used against Obama's campaign. And so it's like, okay, who is it being spent on? Obama. Is it for or against? So it's not that Obama was spending this money against Romney, but this was money spent by possibly random corporations running advertisements against Obama. That's what this giant red thing is. Okay, it's a little bit of a strange system. You think, oh, we just give directly to the candidates and they can spend it however they want. But there's a bunch of like weird rules, and so they have these political action committees that then do stuff. Okay.
So the red bar would mean that the money spent against the Obama campaign.
Yes, this red bar, which is the biggest bar, right? This is a lot of money.
Okay.
A lot of money was spent against the Obama campaign. Yes.
Okay, that makes more sense.
Okay, and not necessarily by Romney directly, but a mix of different kind of political action committees and corporations here. Okay. Your first view quiz answer for today, if you want to jot this down, your first view quiz answer for today is the letter A. A as in apple. A as in apple is your first view quiz answer. Okay? All right, does that kind of make sense? And again, it requires some knowledge and what we call domain expertise. You have to be kind of familiar with how the political campaign spending stuff works in order to really make sense of this graph, where you need somebody to kind of explain it. Otherwise, you can look at this and you'll just be like, ta-da, I'm done, and not realize that this isn't telling the whole story, right? Okay, so, all right, so this, I think, summarizes everything that I wrote, okay? And including the type of spending, whether it was for or against a candidate, is an important piece of information that we need to include, right? All right, and then so there's kind of another question, just overall in the election, did Republicans spend more money than Democrats during the election? And what we can do is we can just kind of look at the graphic that shows total spending supporting or against each political party, okay? And so there's a few different parties, but we can see Democrats, Republicans, DFL is Democratic Farmer Labor Party or something. It's kind of like the Democratic Party, and then some other parties that we just put kind of NA. And so we can kind of, again, it's weird is that, you know, the money that was given to kind of Republican PACs can be spent either supporting Republican candidates or against Democratic ones. And again, money given to Democratic candidates and Democratic PACs can be spent supporting Democratic candidates or against Republican ones. And again, what we see is there was, in general, Republicans did spend more money if we assume this supporting Republicans is by the Republicans and against Democrats is by Republicans, that these two things go together. Yes?
Well, it made me confused. So like the red bar on Democrats is actually spent by Republicans.
Yes, we should think of it that way. And again, it's, you think, well, can you just make a better graphic, right? Like where we are combining this blue part with the red part. So we could, but it, again, requires an assumption that's maybe a safe assumption, maybe one that you don't really want to make. And again, it depends on certain decisions. It's basically the way the Federal Election Commission keeps track of things is just like, is this money being spent on this candidate? Okay, this candidate's a Democratic candidate, and the money is being spent either supporting or going against the candidate, right? So it is confusing that we have to kind of combine this red bar over here with this blue bar over here, but that's just kind of how the data is organized. Now you could go through the data and split it and then recombine it, okay? And again, you'd have to kind of make a statement and say, I'm assuming that this blue part is money spent by Republicans and this red part is money spent by Republicans, okay? But then sometimes you get these political action committees, again, so like in the 2016 election, you'll get like Republicans against Trump, okay? Right? That's a thing that pops up, right? That and you'll have like there could be, Democrats against Biden and things like that, right? And then so it could be money spent against the Republican candidate by other Republicans and things like that. And then so then you have to ask, is this money spent by Republicans, or is it, and so it gets a little bit confusing. So again, the way the Election Commission keeps track of it is just, was it spent for or against the candidate? And then whether you want to assume that just because it's a Republican candidate, that money spent against it must have come from a Democratic Party, you can make that assumption, and that's probably going to be true for 90% of the cases, but not necessarily so, right? Because you will have these political action committees that are things like Republicans against their own Republican candidate because they like a different Republican candidate and things like that. So again, a little bit weird, all right? So if we just think most of this over here is spent by Republicans, probably safe assumption, but not necessarily 100% of this was Republican. Okay, we can just say, okay, well, if we combine this and these two things, which again, I recognize that the graph is confusing in that way, we can see, okay, the overall, this red part and this blue part is bigger than this red part and this blue part over here. Okay, does that kind of make sense as far as what's being revealed? And why also just data graphics are important, but also it's important that things can get lost and confused in your presentation as well. Okay, all right, and so I think this page just kind of summarizes it. And again, very little money in comparison was spent on other political parties. All right, now again, during that election cycle, there were races for House of Representatives, races for the Senate, and the president. And so, and the office of president dominated the election cycle. So we might say, well, let's take a look at some of the other races, okay? And so we could see, this is the total money spent for office of president, okay? This is all the money spent on House of Representatives, okay? That's what this H is, okay? And again, there's, anybody know how many seats there are in the House of Representatives? Yeah.
435.
435, very good. Okay, so there's 435 seats. Okay, and so across all 435, this was the total amount, right? And so, most of the House of Representative races are it's just like in this, they're approximately similarly sized districts and things like that. And, some areas are, lean very heavily one way or very, and they say these are like the safe seats, and then you have these suburban areas which are a little bit more contested and things like that. So anyway, the total of all 435 races added something again like this. And again, maybe we want to make the assumption, maybe we don't, where we assume that the red bar spent against Democrats and the blue bar spent for Republicans is kind of Republican spending, and the red bar spent against Republicans and the blue bar spent supporting Democrats is Democratic spending, okay? And maybe that's a safe assumption, maybe not so much, okay? And so we have this, and then so we could see that, as far as negative spending, the greatest single category here was negative spending against the president, okay? And this is a very large amount here, okay? And so, if you look at some of the other ones, the spending, as far as the Senate and House, the dramatic shift is not as extreme, okay? And in fact, this red bar is a little bit bigger than this red bar, and this red bar is a little bit bigger than this one. Okay. Back in 2012, one thing that was kind of popping up, and again, people always try to make a spin to kind of say, this person is supported by the people and things like that. One question was, was Romney's support just from a few very rich Republican donors, whereas like people across the economic spectrum supported Obama and things like that. And, we could go through and we can just kind of create a plot to see, well, how big was the donation and how much money was received, okay? And so if we do that directly, this is kind of what the plot would look like. We got donations to either, I think this is directly towards donations made towards Obama's campaign and donations directed directly towards supporting Romney's campaign. So again, this is this required looking at an entirely different, not entirely different data source, but it's not the same tables as over here. Okay, this is kind of just money directed towards the actual campaigns themselves, and what we see is a graph that's not very helpful, okay? We just see a very thin, tall bar here, a very thin, tall bar here, okay? And if you look at the scale down across here, this is 0, this is 100,000, and this right here is 25,000, so that means this is something around 12,000, this halfway mark. This would then be something around 5,000, okay? And then so we say, okay, this bar here goes basically from 0 to $5,000, okay? And that pretty much covers every single person I know and can think of, okay? That I might have any, right? Like, how much money have you given to a campaign? And if someone says, I gave $5,000, actually, they could probably only say 2,000 because that's like the limit. I go, wow, you must really be into this, right? Somebody says I gave $2,000 towards a campaign, and you're like, wow, I could have used that money for something else or something, right? You know, but you know, maybe someone really, really supports someone's candidacy, okay? And then over here, you know, like on the 100,000, I have no idea who even could possibly be, right? And so, how does this even work, right? And so, what we just see, okay, well, this bar is taller, but you know, again, this thing is not very helpful, right? Because the scale down here is just so all over the place. So the fact that you've got these very large donations that basically dwarf everything else and just compress everything into a single bar, like in the histogram, okay? And I don't know, well, I guess we never assumed anything. Have you guys seen a histogram before? Okay, maybe, yes, all right. So the idea here is, you know, you got this bin that says, okay, this is all the money, say this bin represents money between $0 and $2,000. How many people gave between $0 and $2,000, and it says 6e to the 5, so I guess that's 600,000 people. I don't know. 10 to the 5 is something around 100,000. So maybe around 600,000 people, a little bit under that, gave somewhere between $0 and $2,000, and then this appears, you know, maybe 350,000 people became $0 and $2,000. But again, that's 0 and 2,000 is such a wide range that it's not that useful to us, okay? So these histogram bins, they're just a little bit too wide, and also the fact that this is, you know, these are side by side, which is fine, but it's also difficult to compare, okay? So here's a graph that tries to kind of fix it. What we've done is we've turned the x-axis into a log scale, right? So down here is $10. Here would be $100. Here's 1,000. Here's 10,000. This line would be 10,000, and this would be 100,000. Okay. And now we can see, okay, this is money spent on Obama's campaign, and so this is the density is kind of a weird thing. Density, the idea of a density curve, rather than just because there might be more people, rather than looking at the actual count, we're looking at kind of the proportion, and so the total area of a density curve is 100%. Okay. And so what we see is, okay, you know, there's kind of a lot here. This is kind of around the $200 spike, okay? And then this, I'm guessing, is something around $500, $1,000, probably $2,000, okay? We got kind of spikes here. All right, whereas over in the, for Romney, you know, we see less of a peak at 200 and more of a peak at kind of 5,000-ish, 2,000 something, okay? And then, and there's a bit of a heavier tail over here, okay? So, you know, maybe that supports that idea. Again, an expert in kind of election cycle stuff would say, you know what, it's actually important to note whether it happened during the primary phase okay, or during the general election phase, okay? Because again, during the primary part, you'll have Republicans supporting, like working against other Republicans and things like that, Democrats working for or against other Democrats, because they're trying to get the one candidate that represents their particular flavor of their particular party, you know, right? Because within, you have, you know, moderate and extreme, or, you know, people on things like that. They're trying to get their, so the spending, whether it was during the primary or during the election, general election, is something that's important. And so if you look at spending during the general election, you can see that donations to the campaigns during the general and election phase is actually quite similar for the two, for both the Obama and Romney campaigns. And it was really during the primary campaign where you had quite a big difference here. Okay. Okay. So all of this stuff, and again, do your reading as well, and it kind of goes over some of the same ideas here. All of this stuff is kind of shows that someone needs to be familiar with the subject matter in order to kind of know how to kind of split apart the data and what graphs would be useful, right? Because sometimes if we just make a graph because we go, oh, I think this would be kind of cool to look at, you can get a graph that is kind of neat to look at, but might not, you know, you could end up getting something that looks like this, and you go, oh, okay, and you might end up thinking you're done, but again, you're missing quite a big part of the picture, quite a big part of, I guess, what story you're trying to tell. Okay. Okay. So when it talks, so I want to just kind of start introducing some of the ideas that come into making a data graphic, and we will get into this later this week. Like we're going to introduce you to ggplot and things like that. Oh. I know there are some questions about like just installing RStudio and things like that. So I posted a little video clips on CCLE, at least for a Windows machine, and then I'll try to make one for the Mac, but should be not too difficult. Okay, and then for Macs, there's now two types of chips, right? You've got the Apple Silicon, the M1 chip, which you have to download a different version of the program versus if you have an Intel chip, which is anything older than, say, a year old, okay? Okay, so what does a data graphic do, okay? So this is a little bit strange, and we'll talk a little bit more about this. But what a data graphic does is it takes basically numeric or categorical data, right, values in your data set, and it maps it to a visual property or a visual cue, right? So there are things, right, something in the data has been mapped to a visual property. Oh, before I forget, let me give you your second view quiz answer for today. Second view quiz answer is the letter B. B as in bear. Bruin. I don't know. What's another B word? Bravo. Beta. Something. Okay. B. So it takes an element in the data and it puts it into a visual cue, something that we can see visually, right? So if we think back to this plot here, okay, it takes the size of the donation, okay, how much money was given, and that's going to determine where it appears in the horizontal axis, right? So the position on the x-axis is the visual cue, right? So we see things on the left and we go, oh, those are smaller values. We see things on the right and we go, those are bigger values. Traditionally, if you have kind of a, smaller values on the left and bigger values on the right, and you can see, and the other part is that when you look at the graphic, your brain says, oh, I see this thing is on over here and the other value is over on the right-hand side. Therefore, the value on the right-hand side is bigger than the value on the left-hand side, right? Where our brain sees the visual things and maps it back into the data space, right? So if you have a good graphic, okay, with a good graphic, if I gave you this tedious homework task, you could actually look at the graphic and recreate the entire table of data itself, right? So from a data table, you're probably used to the homework assignment. I don't know, maybe in 5th grade, you had to make charts for the first time, right? And you were given, here's a table, make the graphic, right? You took like your X, Y coordinates and you did like, I'm gonna plot it over here and things like that, right? But why that's important is because visually you could hand somebody a good graphic, they could take it and they could recreate the actual entire same table based on the graphics that you've given them, okay? And that's basically what we're doing in our brain. We look at a graphic and our brain, using just kind of the visual processing, which is actually fast and good, right? Our brains are made to design, like identify patterns. We look at the stars in the sky. Well, not in California or not in Los Angeles, but you go to, the desert and you look at the stars and you go, wow, there's stars and I can see constellations and it's incredible, right? We see images and stuff everywhere, and we can harness that power along with, okay, now we're also able to map it back to the data space. We're able to recreate that data and draw insights that way, and we can pick up patterns. We can see like patterns where it looks like the dots are in a line and things like that, okay? So that's what we're trying to do, okay? Now, I just copied this chart, and basically there are things that we can use as visual cues, right? So one of the most familiar is just position, right? And this is probably when you made your first plot in 4th grade or 5th grade, you plotted the X and Y coordinate, right? And that basically determined where the dot went horizontally, the horizontal position, and the vertical position. And you put little dots based on your X and Y coordinates. And that was kind of your first graphic, right? You say, I don't know, each student's height and their weight or something. I don't know if you did that or something like that, right? They probably, privacy reasons, we wouldn't do that anymore. But you would do something, okay? But then there's other things, right? So when we're looking at the bar graph, right? That showed the campaign finance, or how much money was spent on each candidate. We looked at the length of the bar. Okay, that's basically like a position thing, but we can look at the length of the bar. And our eyes are very good at spotting things far away, and we could say, oh, you know what, that thing is a little bit taller than that thing or something, right? Like, or we go, okay, that looks even. But you can look at this over here, and you could say, is this, comparing the two boards, you can say, oh, this one is just a tiny bit higher, right? You can detect small differences in height and length and distance very easily, okay? There's other things. We got angle and direction, and you can say, is this sloping, trending upwards or downwards or things like that. Our eyes aren't as good as detecting differences in angle, right? If I showed you two angles and they're kind of rotated in weird directions, and I say, which angle's bigger, it's a lot harder to kind of tell, okay? We've got shape. Shape, you can have dots that are with circles, dots that are triangles, dots that are squares, things like that, little markers. And I could say, the circles are this group of people, the squares are a different group, and the triangles are, another group. Okay, and then other things, you can use the area and volume, the shade of the piece or the color, and they can be used to graph, how big or how extreme or things like that, okay? And again, you want to harness, generally, things like position and heights, you want to use those right away because our eyes are very, very good at detecting small differences in height and length and things like that. Whereas distinguishing between different angles, it's a lot harder, right? So just this is something different, okay? Right, if I were to do something, what's happening there? Right, if I make something like this and something like this, right? You can look at that, and even though it's a very small difference, you can say, oh, this one's taller, right? It's hard. to write, okay? And the other one is a little bit shorter, okay? Whereas if I say, if I give you a circle here, and I give you an angle here, and I give you this angle over here, and I say which angle is bigger, it's hard, okay? Now you might be like, oh, they're the same. But I promise you, I doubt I was so good that I got these two angles to be exactly the same, okay? But if you look at these two things and you say, well, which angle is bigger? It's tough, okay? Or even, I don't know. Okay, which angle is bigger? I don't know. It's hard, right? So this one, are these? Did I truly get a parallel thing? I don't know. So it's those things are tough, okay? Shades and colors, also a little bit harder, all right? So as far as, plotting these things, we've got different coordinate systems, and I think we're very, very familiar with the Cartesian XY coordinate system, okay? But then, probably in high school you learned about polar coordinates, and you had to convert from, r sine theta, et cetera, et cetera, et cetera, to get your x and your y and stuff like that, and so sometimes you want to actually use polar coordinates. I'd say fairly rarely. Okay, mostly you're using Cartesian. But more and more, we're also using geographic position, right? So you get a lot of, now that everybody's got a GPS monitor carrying around willfully, right? We're getting a ton of GPS data, okay? And so you get these two coordinates, right? You basically get a latitude and longitude, right? And we go, oh, okay, I could just plot that in a Cartesian coordinate system. No, you're actually, the Earth is round, okay? And when you plot it into a 2D thing and you get a flat image, okay, things get warped, right? And so things where you think it's a straight line, like the shortest path between two points, two cities on the Earth's surface, when you turn it into a 2D flat thing, it's not a straight line, right? And so you get these kind of these weird things that just don't work out necessarily how you think, especially when you convert from something from the Earth's surface into basically a 2D thing, right? So pretty much all the charts that we make on our computer screen are 2D, but when we're taking things from the Earth's surface, this geographic information, this location data, we got to be careful. We got to be careful because you might be like, oh, I should just draw a straight line. Doesn't quite work out that way, right? Okay, let's see. The scales, okay, is basically, how do we position these things, right? Once you have a coordinate system, so let's just, if we're working in the Cartesian coordinate system, probably your most common thing, you could place things linearly, logarithmically, or percentages. Linear basically just means the difference between 1 and 2, the distance between 1 and 2 is the same distance between 1,001 and 1,002. Okay, and 1,000,001 and 1,000,002. The distance between those 2 points are going to be the same everywhere. Whereas in a logarithmic scale, the distance between 1 and 2 is much greater than the distance between 1,001 and 1,002, right? Because it basically shrinks as you get into these larger numbers, okay? Percentages, these are kind of used for like in the stocks. So if you say, okay, well, let's look at GME versus AMC or something like that, right? And you're looking at, all right. So if you want to look at some kind of stock chart, okay, so you can look at, all right, so when you try to compare these things, right, this is a percentage scale on the horizontal axis, okay? You've got, is it going up or down percentages, which is going to be different, right? You have to, with a percentage, you need to, an arbitrary, this is our 0% change, right? You just take a starting position, starting value, and you compare everything to that. So a log scale, basically, everything, so a percentage thing is a relative difference, but you pick what the starting size is, okay? as far as categorical variables, they can be nominal, not a set ordering. So if you think about, in some of these charts, should the column for Democrats go on the left or the right, Republicans go on the left or right. I mean, there's kind of already a political tendency that kind of makes sense for that. But, if we were talking about like t-shirt colors, right? What order should you put the t-shirt colors, right? You can have red shirts and blue shirts and gray shirts and black shirts and white shirts. And how should these be ordered? There's not a set ordering, right? Somebody wants to put red and blue shirts first and white shirts at the end, fine, okay? Somebody wants to put white shirts up front and then followed by gray shirts, also fine, okay? There's not a set ordering, okay? But then sometimes you have categorical variables where there is a set ordering, right? So if you think about how strongly do you agree, right? Strongly disagree, neutral, agree, slightly agree, strongly agree. There's an ordering going from one end to the other, okay? Never, rarely, sometimes, always. There's a set ordering that makes sense as far as how to arrange them. So you can think of like t-shirt sizes, on the other hand, small, medium, large, they should go in that order. It doesn't make sense to mix it up, right? You arrange t-shirt sizes alphabetically, you're going to get a weird thing. It's going to go large sizes, then medium sizes, then small sizes, then extra large, or XL, or it's a weird thing, right? Okay. Time is numeric, but it's weird. Okay. Basically, the way time works is we said, all right, this is the 0 point. Okay. 0 AD, I guess, or CE, and we just said, okay, this is the 0 point, and then we're going to just measure things based on that, right? And then somehow, universally as a world, we said, all right, 365 days in a year, and 28 days in February, and 31 days in July, and somehow, like, we're all okay with this, okay? But it's weird, right? It's not like there's some astronomical phenomenon that ties it, right? And so that's weird. If you actually look at a computer, everything is measured as how many seconds have passed since January 1st, 1970, 12 a.m., right? And so if you can kind of see this, I'm going to run out of time. I don't get to show you the cool little trick. If you go into Excel and you take just a number and you convert it into a time, it'll basically be how many seconds have passed since then, okay? This context, this idea is, with a good graphic, I said you can give somebody a good data graphic and they can recreate the data table itself directly, right? And that's why probably when you were first making graphics, they said it's very important that you label your axes, right? That you know which values go here, and you have to put little tick marks so you could actually identify where these values are, okay? Because without those, you lose that context. You lose, okay, so we have points over on the left and points over on the right, but I actually have no idea, what do these values represent? What do these points represent? And what kind of scale are we looking at? Is this millions of dollars? Is this hundreds of dollars? Okay, so, and you need to have a legend if you're using different colors. You need to have some kind of legend so you can kind of go back to that, right? Okay. All right. Well, I'm running out of time here. There's a few ways. We've seen some of these things. Facets basically produce multiple graphs of the same thing, right? If you wanted to include multiple variables, like not just party, but also which office, you can put the same graphic kind of all next to each other, but you just change this variable, and that's called different facets. Okay. You can have layers on top of each other. You can have animation and things like that. The other stuff here, basically, read the textbook here. And as far as colors go, you trust expert opinion rather than your own judgment, okay? And then I guess we can pick up on this on Wednesday. We'll talk about dissecting graphics, but then we'll also get into making the graphics themselves. Let me give you your last view quiz answer. Today's last view quiz answer is the letter D. D as in dog. D as in dog. Okay? It's your last view quiz answer. All right. That will be it. I'll probably post a regular homework assignment up in the coming days, so be on the lookout for that on CCLE. You should have all received a link to Data Camp. Okay, please accept that invitation, and you can start your Data Camp homework. Your first Data Camp homework is due this week. All right, we'll see you guys on Wednesday.
Dr. Chen?